Hi guys, my name is Pooja and I will be helping you with the chapter 7 in mathematics, which is coordinate geometry. Now this chapter has been divided into 3 sections and today we'll only be talking about the distance formula. So every video we will cover up 3 different sections and today we'll only be talking about the distance formula. So talking about the distance formula, we will have to go across a few basic terms and only using those we will try and solve a few problems, and then finally we'll end up to the derivation of how we got the distance formula. Now what we have here in front of us is called a graph sheet. As you can observe, this graph sheet is divided into a vertical and a horizontal line. So this horizontal line that you observe here is called the x-axis and the vertical line here is the y-axis. So these lines, if you can observe, they have numbers on them. So on the x-axis we have 0, and then towards the right we have all the positive numbers, and then towards the left of 0 we have all the negative numbers. Then on the y-axis, if you go upwards from 0, you will have all the positive numbers. And then when you go downwards from 0, you will have all the negative numbers. So this is about your x-axis and your y-axis. Now talking about these planes where you can place all different points, this is called your Cartesian plane. Now if you have observed, the x-axis and the y-axis, they meet at a single point here, which is 0. Now that is called your origin. So we have our intersection of x and y at 0, which is your origin. Then we have your vertical axis, which is called your y-axis. Then we have your horizontal axis, which is called your x-axis. So now we'll be talking about something called as the coordinates. Let me give you an example here. Within brackets, if I write the number 2, 3, this will tell us about the x coordinate and the y coordinate. About the coordinates, we'll be learning them on the graph, but for now I will just show you how a coordinate is indicated. So the coordinate points are indicated with 2 numbers separated by a comma, and then they have parentheses, which is also called as brackets. So this first number that you are observing here, which is 2, is your x coordinate. Always the first number after the bracket will be your x coordinate, and the next number will be your y coordinate. So this x coordinate, which in this case is 2, is also called as abscissa. So the x coordinate is also called as the abscissa, and your y coordinate, which in this case is 3, is called an ordinate. So these are the few basic terms that I wanted to talk about. Now how to locate this coordinate, we will look into it with a graph sheet. So here we have taken an example of 2, 3 with 2 as the x coordinate and 3 as the y coordinate. So we'll be plotting this on our graph sheet. So now you have observed that 2 is your x coordinate. So we'll have to locate that first. So how do you locate that? On your x-axis, you will have to go 2 spaces from 0. So it will be 1, 2. So this whole line, the line 2, the vertical line 2, will be your x coordinate. So because this is vertical, and vertical, which means that we are talking about the y-axis, So you can say that the x coordinate, in this case 2, is nothing but the distance from your y-axis, right? Because it is a vertical line that we are talking about. So whenever we talk about a vertical line in graph, we are talking about the y-axis. So we can say that the x coordinate is the distance from the y-axis, because if your point 2 is here, it's the same distance from y-axis. If your point 2 is here, it's the same distance from y, and so on. Now that we have located our point 2, which is the x coordinate, let us locate the point 3, which is your y coordinate. So for 3, we'll have to go 3 spaces upwards, because it is a positive number, right? So we'll have to go 3 spaces upwards towards the y-axis. Now that we go 3 spaces upwards, you know that 3 is this whole horizontal line. So the conclusion that we can make from this is that the y coordinate, which is 3 in this case, is nothing but the distance from the x-axis. So I'll just draw the dotted lines to make it more simpler for you to understand. So this is the x coordinate, which is 2, right? So let us just draw a dotted line here at 2. Now the y coordinate, which is 3, so we'll be talking about this line, right? Now as you can see, these two coordinates, they meet at a point here. So this is your point to be located, which is 2, 3. So after putting a cross right there at the point, you write 2, 3, and this will be your location of the coordinate. Here the dotted line was not necessary. I placed that only for you to understand. It's only this cross mark on the location which was important. So from now on, we'll only be talking about the location of the coordinate and not the dotted lines. So these were the basics to get into the distance formula. Now we'll mainly talk about how to find the distance of an inclined line on a graph. So we can do this with a graph and also without a graph. So with the graph, it will be easier for us. Without the graph, we'll have to use the distance formula. But let us see with the graph how we can do it. So let us take our previous example 2, 3 as one of our coordinates, and let us take another coordinate just as an example. Let us take this as another coordinate of ours. To figure out the x coordinates and the y coordinates, you know that on the x-axis, this point meets here, which is -3. So -3 would be the x coordinate, and then the y coordinate would be +6. So this is your other coordinate. Let us just join both these coordinates. So here is your question. You have to find the distance of this line. So we'll have to figure out a way to find the distance of this slopey line. Now you know that if it is a straight line, it's not difficult for us to find the distance. If I tell you find the distance between A and B, you know that there are 3 spaces between them. So the distance would be 3, right? But here it is a slopey line. You can't just count the number of boxes that it has traced and tell that that is the distance. That would be wrong. So for us to find the distance, we'll have to know about right angle triangles and also the Pythagoras theorem. So let us look into that first. So what we have here is a right angle triangle. When do you call a triangle as a right angle triangle? That is when one of the corners has a 90-degree angle. And we have here this point as 90 degree, and right opposite to 90 degrees, we have this side of the triangle, which is called as the hypotenuse. So if you observe this graph, this line that you just drew a few seconds ago is similar to the hypotenuse, right? What we can do is just draw a right angle triangle with the same hypotenuse and figure out the distance. For that, we'll be using the Pythagoras Theorem. So to understand the Pythagoras Theorem, let us put a few markings on the right angle triangle. So let us name our first side, this side of the triangle, as side A. Then the other side as B. Then let us name the hypotenuse as C. Then according to the Pythagoras theorem, we have the hypotenuse square is equal to the square of the other two sides. So this is your Pythagoras theorem, which we got from a right angle triangle. So the hypotenuse square is equal to a square plus b square. So using this formula, we can find the distance of the slopy line on the graph. Here, you can also say that C is equal to square root of a square plus b square. How did we get this? We remove the square from here, and when you remove the square, on the other side, it becomes the square root. So C will be equal to square root of a square plus b square. So this is the formula that we'll be using to find the distance. But as you can see here, to find the distance of the hypotenuse, you will need to know the distance of A and the distance of B. Now because these are horizontal and vertical lines, it's easier for us to find the distance of a horizontal and vertical line on a graph, because you just have to count the number of boxes or take the coordinates and then decide. So let's go back to the graph and try to understand by creating a right angle triangle on the inclined line. Now coming back to the question, we already have our hypotenuse in place. We just have to draw the other two sides of the right angle triangle. For that, what we can do is, you see these two coordinates, when you try to draw a straight line from them, they meet at this point, right? So we can use that to create the right angle triangle. So here is your right angle triangle, and as you can see, this side makes a 90-degree angle, right? And the side opposite to the 90-degree will become your hypotenuse, which we already know. Now what we have to do is just figure out the distance here and here. So to figure out the distance here, what you can do is count the number of boxes, which is 1, then 2, and then 3. So we can see that it occupies 3 spaces, which means the distance here is 3. I'll also show you how to find out using these coordinates, but first let us go with a simpler way. So 3 boxes, which means the distance is 3. Now let us count the number of boxes here. So it's 1, 2, 3, 4 and 5. So the distance here for this side of the triangle is 5. Now that we know both the sides, we can also figure out the distance of the hypotenuse. So we learned from the Pythagoras theorem that the square of this side plus the square of this side will give us the hypotenuse square, right? So we can follow this formula to figure out the distance. We've already figured out the distance So in this case, your A is 3 and your B is 5. So A is 3. So it will be 3 square plus B. We figured out that B was 5. So B square will be 5 square. This will give you the distance. So figure out what is 3 square and 5 square. 3 square is 9 and 5 square is 25. Now when you add 25 and 9, you get 34. Right? And this is all for C square, not for C. We still have to figure out the square root for C. So anyway, C square would be equal to 34, right? But we wanted only C, not C square. So what you have to do is C is equal to square root of 34. Now if you have learned the division method, using the division method, you can find out the square root of 34. So I've got an approximate for C that is equal to 5.83. Now when you're using the distance formula, you don't really need to find the square root, as the formula would be easier for you to figure out everything. So now that we have used counting boxes as the first method, let us use the coordinates to understand how the distance of the two sides were found. So now these two coordinates is what you already have been given. This is the coordinate that you have to find. So this again would be -3 because it lies on the -3 on x-axis, and on the y-axis it would be 3. Now that we have this coordinate, we can figure out the vertical distance and the horizontal distance. Now for the vertical distance, what you have to do is, you only have to take the vertical coordinates into consideration, which is 6 and 3 in this case. The vertical coordinates, which means the y coordinates. So here the y coordinate is 6, right? And here the y coordinate is 3. So you will only take 6 and 3. And then you subtract 3 from 6 and you get the number 3. So the vertical distance, you can figure it out only with y coordinates, because y coordinate is also vertical. So you will only find out the subtraction of these two coordinates. Now that we know 6 minus 3 will give us 3, and that is your distance for the vertical line here. Now for the horizontal, you know that horizontal resembles the x coordinate, right? So you will only take into consideration the x coordinates of the points here. So this will be -3 and 2, right? So you will have to now subtract these two numbers. So -3 minus 2 will give us -5. It can be -5 plus 5 because anyway you're going to square it, right? So squaring it will give us 25 anyway. -5's square is also 25 and plus 5 square is also 25. So it really doesn't matter if it is plus 5 or -5. I'm talking about the distance. Now that we have both the distance from the coordinates, we follow the same procedure as this. It's just that finding the distance has two methods. Now remember, you will not always be given a graph. You will have to find the distance only by using the coordinates given to you. So that is why I tried to make you understand both the methods. Now that you're comfortable with both the methods, we'll be solving a few problems. Now in this problem 2, we'll try to figure out the distance given by these two coordinates. So this coordinate here is nothing but -4, 1. is your first coordinate. The coordinate here will be 3, 6. Now what we have to do is draw a right angle triangle. So we can take this as one of our sides and then this as one of our sides, and this creates a right angle triangle with this edge as 90 degrees. Now opposite to 90 degree, this side line here is your hypotenuse, and that is the distance that we have to figure out, right? Now you can use your counting the boxes method, but I would prefer the coordinates because not always you will have a graph with you. So we'll figure out the coordinate of this point. So at this point, on the x-axis it will be 3, and on the y-axis it will be 1. Now that we have all our coordinates, we'll figure out the distance from the coordinates. So the distance here, because this is vertical, right? This is vertical and it is parallel to y-axis. So we'll only take 6 and 1 into consideration. So 6 minus 1 will give us 5. Now we'll take this side and find the distance here. So when we take this, it will be minus 4 and only 3. Because this is parallel to the x-axis, we will take only the x coordinates into consideration. So minus 4 and then 3. So minus 4 minus 3 will give us 7, minus 7. So minus or plus 7 is the same thing because you square it and you get the positive number. So anyway, in this case I would write minus 7. So we have minus 7 as one of our sides and we have 5 as the other side. So what we're going to do is square them and add them. So the hypotenuse that we're trying to identify, question mark square actually, is equal to, we have minus 7. So the question mark square, which is the hypotenuse square, is equal to, we have minus 7 as one of our sides, so minus 7 square plus 5 as the other side, so 5 square. So what is minus 7 square? It is the same as positive 7 square. So 7 square is 49 plus 5. 5 square is 25. Now adding these two, we get, add this and you get 74. And 74 is the hypotenuse square, right? But we need to find the square root. We don't need the square, we need the square root. So the hypotenuse will now become square root of 74. So you can find what is the square root of 74. I will just leave that to you. So this is my answer. Now that we have discussed two simple problems, we'll go to the derivation part of this distance formula. So what we'll do here is we'll try to derive the distance formula. And until now, using graphs, we try to find the distance of any slope using a right angle triangle. So what we have here is a right angle triangle. Using this, we'll try to derive the equation for the distance formula. So we know that whenever we try to find the distance of a slope using a graph, we needed two coordinates, right? So that is what I have placed here. One of the coordinates x1, y1, and the other coordinate here x2, y2. And also if you observe here, in our previous example, we got this distance minus 7 and 5 by subtracting the coordinates that were given here. But we also tried to figure out this third coordinate here. So in the derivation, what we are going to do is we don't have to find the coordinate here. Instead, using these two coordinates, we will figure out the distance formula. So now here, we got this minus 7. Minus 7 is the distance of the horizontal line. So we got this minus 7 by just subtracting both the x coordinates, which was minus 4 and 3. So if you take minus 4 and then subtract it with 3, so it becomes minus 4 minus 3, which is nothing but minus 7. And that is how we got the distance here, minus 7. And then 5. How did we get the distance 5? Now you know 5 is a vertical line, which means we'll have to take only the y coordinates into consideration. So we'll take y1, which is 1, and then we take y2, which is 6. So if you subtract 1 from 6, which is nothing but 6 minus 1, you get 5, right? So you got these two distance without really using this coordinate. So we can do the same here for the derivation. So what did we do here? x2 minus x1. And then what did we do here? y2 minus y1 to figure out both these distances. So we'll do the same thing here. To find out this horizontal line. So horizontal is what? The x coordinate, right? So to find the horizontal distance, what we did was x2 minus x1. So we'll note that down here, x2 minus x1. And to figure out this vertical distance, we use the y coordinates. So that will be y2 minus y1. So this will be your distance. This y2 minus y1 is your vertical distance, and this x2 minus x1 is your horizontal distance. Now using this as your distance for both the sides, we will apply the Pythagoras theorem. So what is the Pythagoras theorem? The hypotenuse square will be equal to your sides square summation. So hy, your hypotenuse square, is equal to, what is it equal to? Side square. So what we have, the distance of the side here is x2 minus x1. So it will be x2 minus x1 the whole square, because this whole distance is x2 minus x1. And then what do we do? Plus the distance square here. That will be y2 minus y1 the whole square. And here we need only the hypotenuse, not the hypotenuse square. So hypotenuse is equal to the square. When it goes to the other side, it becomes square root. So we have the square root. And then we write down the same equation inside the square root. x2 minus x1 the whole square plus y2 minus y1 the whole square. And this is your distance formula. So what did we do here in this section? We talked about the basic terms, which is the Cartesian plane, the coordinate axis, what are the x and y axis, origin, abscissa, ordinate. Just take a screenshot of this. These are your definitions for all the basic terms that we have used until now. So these were your basic terms. Then what did we do? We tried to figure the distance of the hypotenuse using the right angle triangle Pythagoras theorem. And then finally we derived the distance formula, which is given by x2 square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now this is your distance formula, and this is what we will be using in our further problems. For now, this was the basics that you all had to know for you to understand the other properties where we'll be using this distance formula.